Today in this video I want to talk about what is a vertical asymptote and how we can find vertical asymptotes of rational functions. Vertical asymptotes are vertical lines that the function approach and get very close to these vertical lines. Knowledge about vertical asymptotes is very useful in sketching the graph of the functions. Note that all the functions do not have vertical asymptotes. Some functions, like rational functions, may have vertical asymptotes. And easily we can find vertical asymptotes of rational functions. To find vertical asymptotes of rational functions, always follow these steps. If it is possible, factor numerator and denominator of your rational function. Then cancel any common factor from numerator and denominator, if there is any common factor. After you simplified your function in step 1 and 2, go to the next step. Set denominator equal to 0 to find the vertical asymptotes. Let's try an example. Y equals 2x plus 1 over x minus 1. The first step is to check and see if it is possible factor numerator and denominator. But in this simple example, there is nothing to factor in numerator and denominator. So we go to the next step. Cancel any common factor from numerator and denominator. In this simple example, there is nothing to be cancelled from numerator and denominator. So we jump to the next step. Set denominator equal to 0. If we set denominator equal to 0, from this equation we have x equals 1. So x equals 1 is the vertical asymptote of this rational function, and we don't need to do anything else. But before we jump to the next example, let me show you what it means that x equals 1 is the vertical asymptote of this rational function. Here you can see the graph of this function, and this is the vertical line x equals 1. As you can see, our function approaches this vertical line. It gets closer and closer to this vertical line, and it shows that this vertical line is the vertical asymptote of this function. Another example. Suppose we want to find vertical asymptotes of this rational function. Y equals x plus 5 over x squared plus 5x plus 6. As the first step, we should factor numerator and denominator, if it is possible. In numerator, we have x plus 5, which is a simple function, and there is nothing to be factored. So we go to the denominator. In denominator, we have a quadratic form. To factor this quadratic form, we should try to guess two numbers that their product is 6 and their sum is 5, and put those numbers here and here. Their product is 6, their sum is 5. Those numbers are 2 and 3. The next step is to cancel the common factors from numerator and denominator, if there is any. If we look at the numerator and denominator, there is no common factor. So to find the vertical asymptotes, we go to the last step. We set denominator equal to 0. Denominator of our rational function is x plus 2 times x plus 3. We set it equal to 0. We know that when the product of two expressions equals 0, we should separately set them equal to 0. So we have x plus 2 equals 0 and x plus 3 equals 0. Now is the time to solve each of these equations for x to find vertical asymptotes. From the first equation, we have x equals negative 2, and from the second equation, we have x equals negative 3. So x equals negative 2 and x equals negative 3 are vertical asymptotes. Let's take a look at the graph of this function and the vertical asymptotes. As you can see, the graph of the function approaches and gets closer and closer to these vertical lines, but never touches or crosses these vertical lines. It just gets closer and closer to these vertical lines. Note that you don't have to graph these functions. Here I am sketching the graph of these functions to show you the meaning of vertical asymptotes for a function. Let's see another example. Y equals x minus 2 over x squared minus 3x plus 2. The first step is to factor numerator and denominator. In denominator we have a quadratic form. We should find two numbers that their product is 2 and their sum is negative 3. Those numbers are negative 2 and negative 1. After we factor numerator and denominator, we should cancel the common factors. The common factor is x minus 2. If we cancel x minus 2 from numerator and denominator, our function will be simplified to y equals 1 over x minus 1. Now we should set denominator equal to 0. If we set denominator equal to 0, we have this equation, x minus 1 equals 0. If we solve this simple equation for x, we have x equals 1. So x equals 1 is the only asymptote for this rational function. Let's take a look at the graph of this function and its vertical asymptote. This dashed line is x equals 1. And again, as you can see, the graph of the function approaches and gets closer and closer to this vertical line. Before we see the next example, let me show you what happened to that cancel term. What was the effect of cancelling x minus 2 from numerator and denominator? When we cancel x minus 2 from numerator and denominator, it creates a hole on the graph of the function. As you can see, there is a hole on the graph of the function at x equals 2, and the function is not defined at this point. Let's try another example. We are asked to find vertical asymptotes of the function y equals 1 over x squared plus 1. As the first step, we should try to factor top and bottom. In top, we have a constant, so there is nothing to be factored in numerator. In denominator, we have x squared plus 1. Denominator cannot be factored as well. Note that if instead of x squared plus 1, we had x squared minus 1 in denominator, we could factor denominator by the difference of a square's identity. But because it is x squared plus 1, it cannot be factored. And there is no common factor between numerator and denominator, so there is nothing to be cancelled from numerator and denominator. And we should go to the next step. We should set denominator equal 0 to find vertical asymptotes of the function. So we set denominator equal 0, we get to the equation x squared plus 1 equals 0. From this equation we have x squared equals negative 1. Note that in the left, x squared is a positive expression always. For any value of x, x squared is always positive. In the other side of the equation, we have a negative value. A positive value cannot be equal a negative value. So we can conclude that this equation has no answer. And so this function has no vertical asymptote. Let's take a look at the graph of this function. As you can see in the graph of this function, there is no vertical asymptote for this function. It has only a horizontal asymptote, which is another story for itself, and we'll talk in another video about horizontal asymptotes. But this function has no vertical asymptote.